Now right here, you want to find the signs of trig functions from the quadrant we are given right there. So we have the sine, the cosine, the tangent of all these right here. Okay, now we have this circle, and this circle is divided into 4 equal parts by the 2 perpendicular lines from here to here and from here to here. Okay, great. Now we notice that from here to here makes it 90 degrees, same thing as from here to here and here to here and here to here. So all together we're having 360 degrees. Great. Now we divide this into 4 equal parts this way. Now each of the quadrants or each of the segments, 1, 2, 3, 4, okay, with the black marker has 90 degrees. So we have here to be from 0 to pi by 2, which is something as 90 degrees, and others as you've seen like this. Okay, so you want to use this to determine the sine function, cosine function, tangent function for each of these quadrants. Now we used to get the notation where you say that right here, all of them, like the 3 of them are always positive. Right here we have that only sine is positive, and here we have that only tangent is positive, and lastly we have that only cosine is positive. We want to show you how this came to be. Okay, great. I want you to stay to the end of this video, and I believe you go back with something. All right. Now I want you to consider the angle in the first quadrant. The angle we're considering is the angle theta. Okay, let's say that theta moves from here to this point. We call that theta. And notice that on your xy plane, we observe that from here right here is always what? The part greater than 0 is always the positive x-axis, just like we have it here. And backward we have the negative x-axis, up we have the positive y-axis, and down we have the negative y-axis. All right. Now I want to believe that having a right angle triangle produced here, for example, and you have your angle to be here, theta. So the sine of theta will be what? Opposite over hypotenuse. Okay. Notice that this is a circle, and a circle has radius to be the same at all points. Okay. So this is the radius r. This is the radius r. And this right here is the radius r. So the radius is the same for all the lines from the center to any point at the circumference. Okay, great. So we're going to make use of this radius to be our hypotenuse side, which is the longest side on a right angle triangle. So we go ahead and say that sine function given as sine of the angle theta will be equal to y over, which is opposite over hypotenuse over r. Okay, and you know that this is positive, positive y-axis, positive, and r is positive, therefore the result it will be positive for what our values of y and r is. These are positive results, so the sign there will be positive. That's simple. Okay, so we go ahead for cosine. We have that cosine theta is going to be what? Adjacent over hypotenuse. So the adjacent here just have cosine of theta to be equal to, now adjacent there is just x over our hypotenuse there is just r. Okay, great. And you notice that this is also positive because here is positive and here is positive, therefore the result is going to be positive. Okay, now we go again for tangent of this right here in the first quadrant. We have the tangent is noted to be what? Opposite over hypotenuse. So we have opposite to be y, and we have tangent of theta is equals to, opposite is said to be what? Opposite is said to be y over the adjacent, which is x. Both of them are in red, and we still have positive, the result is positive. So we still have a positive result. Therefore, in the first quadrant, okay, when the angle lies between 0 and 90 degrees, then the sine of those angles, the cosine of angle, the tangent of any of those angles will be positive. That's what it says. Okay, great. We are done with the first quadrant right here. Now we go move over to the second quadrant to show that only sine is positive. Now we notice that here we are now dealing with angle alpha, no longer theta here. Okay. So the sine of the angle alpha will now become opposite over hypotenuse. That is y over r. That is opposite over hypotenuse. And we go again for cosine, opposite over hypotenuse. Now cosine of the angle alpha will now become adjacent over hypotenuse. That is, since we're on this part right now, so this is negative, adjacent over hypotenuse, so we're going to have negative x over the hypotenuse side, which is r. So at this point we have negative, okay, is there only in the numerator, not in the denominator, therefore the quotient there will be negative. this was positive, right? So sine A was just positive. So cosine A is now negative. Let's look at tangent of alpha at the second quadrant. We will notice that tangent is equals to opposite over adjacent, where we have y over negative x. Okay, so y here is positive, negative, x is negative, therefore the result will be negative. So in the second quadrant, it's only sine s that is positive, the rest are negative. Just go over the same method I will allow you to do for the fourth quadrant. So watch this. Okay, now here we have this is r, not v, don't be confused. Now the sine of this, let's start with the sine. The sine of angle beta b is equal to what? It's opposite over hypotenuse. Take note, this is the hypotenuse side, this is the right angle, angle 90, and this is the angle. So opposite to the angle is negative y over the hypotenuse is the r here. So this already is negative. Okay, so we move over to the cosine of that angle. We have cosine of beta, and we have it to be equal to, and notice that cosine is adjacent over hypotenuse. So we have the negative x over hypotenuse is r, and the result is still negative. Look at tangent. Tangent will be what? You know, opposite over adjacent. So tangent of that angle beta is opposite, which is negative y, divided by adjacent, which is negative x. Okay, great. You know, the numerator is negative, the denominator is negative, therefore the result will be y over x. Where we have negative 1, we'll cancel out with negative 1. We have only positive y and x, therefore tangent at that point is positive. So you apply the same thing right in this fourth quadrant, and you would have that the sine will be negative, the cosine will be positive, and the tangent will be negative. So these are the signs for the first quadrant, second quadrant, third and fourth quadrant. Okay, great. I hope you enjoyed the video and you've understood and know why it is so. Thanks for watching. Please subscribe to this channel.